Welcome to Web Handling. My name is Dave Roisum. In this clip, we begin a series on nips with some tips for piping. Many of you have heard jokes, such as the definition of a seal is a place for a leak. But leaks are no joke, and virtually all can be prevented with suitable attention to design and maintenance. For good response, piping should be short and equal length to both sides of the machine. The usual procedure is to pipe to the middle of the machine and then tee off to both sides with equal legs. You can never have too many gauges, especially for vital process controls like nips. In an ideal world, there would be a gauge at the cylinder and perhaps another on the benchboard for certain components. Pneumatic control brakes on unwinds would be one example, because it is easy to get out of a good pressure control range when running different grades from full diameter to the core. Finally, if humans are working in proximity to systems with potential energy, it may be a good idea to put a pilot-operated check valve at the cylinder side that does the lifting. An example would be an overhead rider roll on a 2-drum winder. We would not want a line brake to drop the assembly on a poor operator working underneath. The gold standard for piping many systems is to pipe on both sides, even if all required functions can be accomplished with one side only. Here, the fixed side counterbalances assembly weight. The control side does the work on the product. There are many advantages to this approach. Under certain cases, such as an inverted cylinder with very heavy assembly, all of the tear and control is on one side. Here, we do the summing of the two separate loads in the PLC, but still rely on thorough documentation on how to set the zero. While one side is called fixed, it is only fixed during run. You can have other regulated pressures during raise, lower, and other conditions. The purpose here is to zero out the weight of the assembly. Then, zero pressure on the control side yields zero nip on the product, a quite sensible expectation. This also means that a higher pressure set by the operator will yield a higher nip for the assembly, given in the previous slide. Also, a quite sensible expectation that is not always met, especially on many converting winders. Of course, we would never allow the operator to adjust the fixed side. This would be done by a service or maintenance engineer using a procedure given in the service manual. Of course, as I have admonished on many occasions, nip load is not in PSI. It is PLI in the product, the universal web units for strength, tension, nip, and motor torque in the U.S. system of units. Using PSI as an operator setting for nip is like using milliamps of load cell for a tension setting. Absolutely absurd. So why do we do it? Culturally embedded control engineer laziness. Finally, there are many ways to end up with a poorly sized control system, especially with pneumatics. These systems should run in the 7 to 70 psi or 0.5 to 5 bar range. Finally, excessive mechanical friction will debilitate any nip control system, as we will describe in the next clip. Thank you so very much for watching this module in my Plant Practical series. Stay tuned for more clips on nips and other web handling topics.